Look at the circle. Now, learning goal here, we're going to recognize and determine the features of this graph here. X squared plus y squared equals r squared, and this is its general form. Okay, including shape, centers, and radius. Alright, our little success criteria here. Okay, so we've got this example here, x squared plus y squared is equal to 3 squared. Okay, because that's what 9 is. 9 is 3 squared. And so for this relation to just hold true, to define a circle, we can kind of see this should be sparking Pythagoras' theorem straight away. Okay, we've got a squared plus b squared equals c squared, where c is our hypotenuse. Okay, well, we can just draw a right angle triangle as long as we've got a straight line hitting any point. Okay, and so we could dot this down. That would be a right angle triangle here. Okay, with this distance would be the y-axis, and this distance here would be the x-axis. And so if you took x squared plus y squared, you would get that's equal to 3 squared by the definition of this relation here. And you could just map that around the entire circle. So you could pick this point here. Okay, that's the center of our circle. And we'd have, dotted down again. This distance here would be y. This distance here would be x, and so you have x squared plus y squared again would have to be equal to 3 squared. And so if you take that for all of those x and y points, you get a circle. Okay, so we're going to look at sketching them, and they've got a general form. That's this guy here. So x minus a squared plus y minus b squared is equal to r squared. Okay, this means that we've got a center at AB. Okay, because that's just our vertical and horizontal shifting around the axis, and the radius is equal to r. So when we are sketching, what we need to do is we need to find or identify the radius and the center. We need to mark the endpoints of our circles, r units out from the center, scale and label the axis, and then sketch an appropriate circle. So we've got something like this here. Okay, sketch the following relation, right, which we can identify that it's a circle, state the domain and range. So first thing I can spot is it's got a center at 3, 0. Okay, because I could write this in the form as x minus a squared plus what? Do that again. X minus 3 squared plus y minus 0 squared is equal to, well, I can say that's 2 squared, because 2 squared is 4. So the radius at 3, 0 and center at 3, 0, radius equal to 2. Okay, well, that's kind of nice, because now we can just go ahead, we can start sketching this. Alright, we can plant a dot right at our center, which is at x being 3, y being 0. X being 3, y being 0. That's our center. And then we refer back, mark the endpoints, r units out. R being the radius, so we go 2 units up, 2 units to side, 2 units down, 2 units across. That's step 2. Step 3, okay, scale and label and mark the considered points. That's what we've done. And then step 4, we just draw an appropriate circle. Let me fix that. Okay, and so this is our circle where we've got, that's x minus 3 squared plus y squared equals 4. That's that relation. And then the domain. And so we can have a look here. We've got our domain. Alright, so we can see here inclusive x input points 1 to 5. And the range goes from -2 to 2. Okay. Also want to point out here, okay, how we can also do domain and range. is that for this, I guess, endpoint, we can take the center, so that's the x point of the center for domain, which is 3, and we can subtract the radius. And then we can add the radius, because you can kind of think of it as, here's our center, and we're going 2 units, let me do this in a graph. Here's our center, and then we're taking away 2 units to get to that left endpoint, and then we're adding 2 units to get to that right endpoint. And so you can close that off again with our range. We can go, starts at 0, subtract 2, because that's our radius, and then 0 plus 2. So when you simplify that out, we get what we had up there, which is 1, 5 for the domain, and -2 and 2 for the range. Alright, so here we've got this example 2, identify the center, radius, domain, range of this following expression. If I need to find radius and center, I need to put it into this form here. X minus a squared plus y minus b squared equals r squared. And so if we look at this expression here, okay, I can see that the coefficients of x squared and y squared need to be 1. So I will divide everything by 2. So every single term is going to get divided by 2 on this side and this side. And so when I do that, we'll get x squared plus y squared minus 3x plus 2y plus a half equals 0. Okay, and now I need to complete the square for this guy here. So I'll put my x terms together, and then I'll put my y terms together, and I'll take this half and throw it on the other side of the equation. Okay, now here to complete the square, I need to halve this b term and square it, plus it and minus it. Again here, plus 2 on 1 squared minus 2 on 1 squared. The way that we've set it up, we've put it so that we can complete the square. So we've got x minus 3 on 2 squared, subtract 3 on 2 squared, plus y plus 1 squared minus 1 squared equals negative a half. Okay, and we kind of think, so I've seen this technique before. This just became that, and this just became that. Okay, that's why we put it in this complete square form. And then with these constant terms here, so this guy here and this guy here, we need to throw it onto the other side of the equation. And then we just need to simplify this right hand side. So we've got x okay, continuing the work along up here, we'd have x minus 3 on 2 squared plus y plus 1 squared be equal to minus 2 plus 9 plus 4 be 11 on 4. Okay, and so now we can state a few things. We've got center at this point here, radius is equal to the square root of 11 on 4. With this radius here, we can we can simplify that down to root 11 on 2. Show you the working. This radius, we can simplify it down to root 11 divided by root 4, which is equal to root 11 on 2. So that's our radius simplified, which is nice. And now we just need to state domain and range. So in our domain is our x center point, which is 3 on 2, subtract the radius, and then the end bound is 3 on 2 plus the radius. Okay, we can simplify that. So we've got a domain of 3 minus root 11 on 2, and then 3 plus root 11 on 2. So that would be our stated domain. We can do a similar thing for range, squeeze it in here. Okay, we know that we're going to have negative 1 minus root 11 on 2, and then negative 1 plus root 11 on 2. Okay, because we're using this center point here, AB. This is A is input, B is output. And so that's input domain, output range, and that's how it affects it.